Hi folks, welcome to 1 Minute Math. Today you're getting the extended cut of absolute value equations. So in this video, we're going to go through what an absolute value equation is trying to communicate to you, how you can solve it, how you can interpret your solutions. So an absolute value equation, by that we mean any kind of equation, so that equal equation means it has an equal sign in it. Any sort of math sentence that has an equal sign in it, and it's got some absolute values somewhere. So the most simple example would be the absolute value of my variable equals a number. In this case, absolute value of x equals 3. A quick refresher on absolute values. Absolute value just means distance from 0. So if I ask you the absolute value of 2, it's 2, because 2 is 2 away from 0, right? If I drew a number line, there would be 2. Bang. 1, 2, absolute value of 2 is 2. But that means that the absolute value of -2 is also 2 because its distance from 0 is also 2. So the absolute value of an expression of a number will always equal a positive number because it represents a distance, but the stuff that's inside the absolute value can be positive, negative, or 0. I guess I should have qualified. The absolute value of a number can equal 0 if that number is indeed 0. So positive or 0. But the absolute value of a number or an expression will never equal a negative thing, but I can put negative things inside the absolute value. That's a common issue that we have with absolute values. So now let's think about this expression, this equation we have. If the absolute value of x equals 3, what number or numbers could x be and have the statement be true? And one of them is pretty obvious to me. X might equal positive 3 because the absolute value of 3 is 3. But based on what we saw over here, is there another number that I could put in here and still get positive 3 as my answer? And hopefully you've already beaten me to the punch here, and you know that x equals -3 will also make the absolute value of x equal to 3. So I get two solutions. And I could write it that way. I could write x equals 3, x equals -3, or I'm allowed to write one sentence where I say x equals 3, comma, -3. That means x is either going to equal 3 or -3. Those are my two options. Some equations, if you go further in math, you're going to see equations that have 3, 4, 5, even infinitely many solutions that might fit a pattern. So we can write x equals and then have a bunch of things separated by commas. Here in absolute value land, we're either going to have one or two solutions, or sometimes 0. We'll see one of them later. Okay, so now what happens when the stuff that's inside the absolute value is more complex than just x? If I had said the absolute value of, I'm going to come up with another symbol or variable. I'm just going to say blob. If I say the absolute value of blob equals 8, based on what I did in that last page, I know that blob could be 8 or -8. So does that mean that x here, let's see if I solve this, x plus 3 equals 8, x equals 5. Does that mean that x could equal 5 or -5? Well, let's try that. Let's plug them in and see. The absolute value of 5 plus 3 would be the absolute value of 8 is 8. Check, smiley face. Yay, that one works out. The absolute value of -5 plus 3. Ooh, this is not looking good because -5 plus 3 is -2, and the absolute value of 2 is 2, which is not 8. So I can't just solve my equation and then throw a plus or minus sign on it. But what I can do is take the stuff that's on the inside here and put a plus or minus on, like that can be positive or negative. X plus 3 could equal 8, or x plus 3 could equal -8, just like I had over here. Absolute value of blob equals 8 means the blob, or in this case, x plus 3, is either going to equal the positive 8 or the -8. And now I have two equations that I can solve. X equals 5, or x equals -11. We knew this one worked out from before. Let's just check this one. -11 plus 3 is -8, and the absolute value of -8 is 8. Yay, they both work. So the moral of the story here is, when I have the absolute value of some kind of junk, the absolute value of some expression, and it equals a number, I am going to set this junk, this stuff, I'm going to make two equations out of this. This is really like code for two different equations, where that junk, the 2x minus 5, is either going to equal +11 or it's going to equal -11. And now I just have to solve those equations. So from here, you should feel comfortable solving equations of this form. If you're not feeling great about it, you can go back and look for one of my other videos, which is about solving 1 or 2 step equations. That's what we're doing here. So we've got x equals 8 on this side. It's 5 plus 5. You'll notice that I am doing the exact same operations on one side or the other, one equation or the other, but they are producing different results. And in this case, x equals -3. My two solutions here are x equals -3 or 8. Again, we take the junk that's inside, set it equal to the positive or the negative of the number that's on the other side, and then solve those equations. Now, sometimes we get junk that's outside of the absolute values. And in this case, we're going to treat this as our primary goal. We kind of have to reframe what we think the variable is for a minute. I've got 5 times, let's use a triangle, 5 times something minus 1 equals 14. And the first thing I've got to do is isolate that thing. I have to do some algebra so that I get to a point where I have absolute values of stuff equals a number. I'm going to treat all that absolute value stuff as its own variable and try and get it alone. And I've got the 5 on the outside. We're going to divide by 5. That gives me absolute value of x plus 2 equals 3. Now I'm at liberty to split this up into 2 equations. X plus 2 could equal -3, or x plus 2 could equal +3. 2 minus 2, so x is going to equal 1 or -5. And you can go back and check those. If you plug those in, you can check to see if they actually produce the result that you're looking for. I'll leave that up to you. We've got one more example here because on this one, something funny is going to happen. When I subtract 5 from both sides here to try and get the absolute value alone, I get the absolute value of x plus 1 equals -2. If you remember from the very beginning of this video, or maybe you want to go back and look at it again, you'll remember me saying that the absolute value of an expression or a number can never equal a negative number. This is kind of a trick question. It's got no solutions because the absolute value of anything is always greater than or equal to 0. So let's say we missed that. Let's say we forgot that we couldn't have the absolute value equal to a negative number, and we proceeded with this the way that we would have if we did have an equation with solutions. So I'm going to set my junk that's on the inside equal to the positive and the negative of the number that's on the right, and I'm going to try and solve for x, and I get x could equal -3, or x could equal 1. This is why it's always a good idea to go back and check. If I plug that in here, 1 plus 1 is 2. 2 plus 5 is 7. That is not equal to 3. If I try this other one, if I plug in -3, -3 plus 1 is -2. The absolute value of -2 is 2, and 2 plus 5 is 7, not -3. And you can see that neither of those numbers actually works. So just be on the lookout. If you have a quiz or a test coming up on absolute value, it would not surprise me if your teacher puts one question on there that's going to be kind of a trick question like this, where you end up with the absolute value of something equals a negative number. As soon as you see that, you can say no solutions. And if you want to, you can check every time you get to the end of the equation, you have 1 or 2 x values, go back and plug them in and just very quickly verify that they actually make sense and don't give you a weird result like 7 equals 3. Okay. That's it for this. I hope that you found this helpful, and be sure to like and subscribe. Thanks.